Good morning, and I feel really sad that I could not be with you in person today in Cairo. And I was planning tomorrow to go visit the pyramids, so I guess I will still have to make a visit next time. I would like to thank Professor Amal Bishlawi and the organizers for inviting me, and I'm going to be talking today about novel therapies for sickle cell disease. And in fact, I'm glad I'm late. These are my disclosures. But I'm glad I'm late because after the excellent presentation by Professor Al-Ghamrawi on the pathophysiology, I don't need much to say, except that the single amino acid that in sickle cell disease leads to severe complications in pathophysiology, including adhesion, oxidation, inflammation, and starting with sickle cell polymerization. So the pathophysiology has been well described. Now we know that we have now 5 approved therapies, and I'm going to talk about some of them: hydroxyurea, glutamine, crizanlizumab, and voxelotor. I'll be discussing Criz and voxelotor a little bit later, but more important to know that there are many ongoing and potential trials, and many of the colleagues in Egypt and Lebanon are participating in these trials. As you heard, fetal hemoglobin is an important modulator of polymerization. Fetal hemoglobin will decrease polymerization, interfering with the polymerization, and thus interact at the basic site of the pathophysiology of sickle cell disease. And as you saw, fetal hemoglobin may play a role in decreasing a number of symptoms in sickle cell disease, including aseptic necrosis, acute chest, hospitalization, and this is showing the fetal hemoglobin levels with the decrease in the incidence of these events. So this we know from naturally occurring variants, and now we have 2 ways of interfering with fetal hemoglobin. One of them is biochemical, and the other I'll talk later is gene therapy. Now, hypomethylating agents that interfere with DNA methyltransferase enzyme like tripazocytidine and decitabine are being proposed. Of course, we know that hydroxyurea also works partially through decreasing methylation. Now, there are experimental studies on an orally administered preparation of PHU thiouridine with 5-azacitidine, and this will allow the 5-azacitidine to be better absorbed. And in this experimental study, we noticed that in these patients at a high dose, there was an induction of fetal hemoglobin, an increase in hemoglobin, a decrease in reticulocytes, and a decrease in Fs, an increase in F retics as well. So one potential, and I hope this will be entering clinical trials soon. Now, what about anti-sickling agents? Today, the only directly acting anti-sickling agent we have that has been approved is voxelotor. The same company, GBT, has another agent that coming in. Voxelotor is a small molecule that binds to hemoglobin and prevents release of oxygen, and therefore prevents polymerization. As we know, it's the deoxygenated hemoglobin that polymerizes. This hopefully will decrease vaso-occlusion and prevent end-organ dysfunction. Now, we have shown and we know that this is where the molecule binds to the alpha chain of hemoglobin, and this was the original HOPE study, the phase 3 trial of voxelotor that looked at voxelotor 1500 milligrams, 900 milligrams versus versus placebo, and these were the characteristics of the patients, multiple pain crisis, and the primary endpoint was an increase in 1 gram per deciliter of hemoglobin. There were multiple secondary endpoints, including change in hemolysis, annualized rate pains, and we will show you these results. So the trial showed that at the higher dose, voxelotor was effective in increasing hemoglobin by 1 gram in at least half the patients, and there was an absolute increase in hemoglobin in about two-thirds of the patients involved. Now, these were studies mainly in adults. Since then, we have participated in a number of studies in children as well that have shown exactly the same thing, and voxelotor now is approved down to 4 years of age. You can see here that also important, the proportion of patients whose hemoglobin decreased over time were many fewer in the voxelotor arm compared to the control arm. These changes in hemoglobin at the higher dose were sustained over 24 and then even 48 and 57 weeks. Now, what was somewhat unexpected is that there was a trend, but not a significant decrease in the annualized rate of pain and vaso-occlusive crisis over time. And the reasons why that is are being debated, but there was no increase in pain, but there was a non-significant decrease in the number of vaso-occlusive episodes. So in conclusion, voxelotor increased at a dose of 1500, increased hemoglobin to a mean of 10 from a baseline of 8.6, decreased, there was an improvement in hemoglobin, reticulocyte counts, but did not meet the secondary endpoints of decreasing pain, fatigue, and vaso-occlusive crisis. However, there is many patients who report significant benefit in improving their activity over time, and we have recently published this in a review that's about to come out. Now, there is an important model that has been developed and was published recently in Blood that claim that because there was of the increased binding of oxygen, there was decreased oxygen delivery to by voxelotor except at very low oxygen tensions, and this is they believed why voxelotor was not effective in pain crisis reduction. However, if this model is a good model, but it's a model nonetheless, and if this were really true, then we would really see an increase in pain crisis because of decreased oxygen availability, not a non-significant decrease. So there was no increase in pain crisis, so we still have to look at this mechanism closely, and perhaps other drugs might come on that will improve on this in the future. Now, it's important that it's still voxelotor increased hemoglobin levels, and this is being beneficial to patients. What about cell adhesion blockers? We saw again the detailed presentation of the pathophysiology, and that selectins are very important in the adhesion of white cells, platelets, and red cells to the endothelium, and are critical in the formation of the vaso-occlusive clot and the later activation of other adhesion molecules. You heard about the toll-like receptors and so on. So crizanlizumab is a new molecule targeting P-selectin. It's a P-selectin inhibitor that will prevent the binding of leukocytes and platelets to endothelial cells. It's a humanized immunoglobulin 2. And this was the initial trial where there was a dose of 2.5 grams per kilo, and placebo, and milligrams per kilo. And compared to placebo, the dose of 5 milligrams per kilo decreased the annualized pain rate by 45%, and had a significant improvement. And here you can see the 5 milligram per kilo, the 2.5, and the placebo, and the significant improvement in pain crisis rates with this molecule. The side effects were very tolerable: arthritis, some diarrhea, some vomiting, and some infusional-related pain. And again, the time to first sickling episode and second sickling episode was significantly prolonged in the patients receiving crizanlizumab. The adverse events that occurred in 10% or more of the patients were, as I mentioned, very tolerable. Now, there are a number of ongoing studies with crizanlizumab, including looking at the drug in adolescents, and also we are involved in a trial looking at 7.5 milligrams per kilo versus 5 milligrams per kilo, and see if we can improve the effect. Now, you heard a lot about nitric oxide, and this is, I'm not going to go through this in detail again, but to say that there is a nitric oxide depletion among patients with sickle cell disease because of nitric oxide scavenging by the plasma-free hemoglobin. And one important precursor to nitric oxide is arginine, and in patients who were given arginine during a pain episode, this was shown to significantly decrease the pain score at the time of discharge, and also it decreased the total opioid dose used among patients in the hospital. So arginine seemed to be a beneficial adjunct by increasing nitric oxide. My colleague, Dr. Claude Morris, is conducting a larger study on this, and we're going to await for that. Another potential pathway to increase nitric oxide was the blocking of phosphodiesterase 9. I'm not going to spend long on this. The trial of this IMR 687 that blocks PDE9A was recently closed because of lack of efficacy. New agents coming down the block, and now I have to just quickly mention voxelotor and crizanlizumab are approved. All the other agents I'm talking about are still experimental. Now, what about targeting tyrosine kinase? It has been shown that in sickle cell patients there is a decreased activity in the stability of the pyruvate kinase enzymes, and there have been a number of activators of these enzymes that have been developed to treat patients with pyruvate kinase deficiency. One of them is from Asia, SMITA-PVAC, and the other is a TACO-PVAC from Forma, and we can show that these can have significant impact on red cell health by increasing ATP and having an impact on 2,3-DPG. I'm going to show you this in this diagram where PVAC activates pyruvate kinase, and you're going to have an increase in ATP within these red cells. This is also going to lead to a decrease in 2,3-DPG, and therefore this is expected to decrease hemoglobin, to decrease hemolysis, increase hemoglobin, and decrease veno-occlusive crisis. Now, the TACO-PVAC or the other drug could have potential improvement in sickle cell and RBC health at multiple points in this pathway. As we said, decrease to 3-DPG, increase ATP, decrease hemolysis, decrease phosphatidylserine on the RBC membrane, increasing antioxidant enzyme activity, and decrease procoagulant biomarkers. And this is going to lead to a decrease in ischemia and perfusion injury, free heme, and decrease sickling. Now, whether this all will pan out in the clinic remains to be seen, but in initial studies have been encouraging. For etapopivak, and both mitapivat and etapopivak have demonstrated this, but here I'm showing data for etapopivak from Forma has shown an increase in mean hemoglobin, and in these, and 7 out of the 8 patients had an increase in hemoglobin of more than 1 gram per deciliter, and there was a maximal hemoglobin increase of about 1.6. There were decreased markers of hemolysis, including absolute retic count, bilirubin, and LDH by 12 weeks. And now we are starting the hibiscus study, where we are going to go in a randomized fashion to look at dose determination and long-term safety and efficacy of this trial after 1 year of use. Now, I want to talk briefly about gene therapy and gene editing, and just very briefly, we talked about improved fetal hemoglobin, and I said that this can be done through drugs, hydroxyurea being one, and decitabine being another, but there are molecular or genetic mechanisms to look at hemoglobin induction, and these are now the part of gene therapy, mainly looking at knockdown or silencing of the BCL11A gene, and we'll talk about that. Gene correction has recently entered into the arena. The first patient has not been enrolled yet, but there is a new trial from Graphite, and gene addition is very well known. Gene addition is adding a new gene to stem cells using a viral vector to deliver a non-sickling hemoglobin to the stem cells. And today we have 2 non-sickling hemoglobins that have been tried. I'm going to show you both of those. And the virus is chosen as a vector to get the DNA into the cells. Now, once the DNA is in the cells, it's not going to really hopefully alter the DNA of the cells, but still this needs a mobilization of stem cells and chemotherapy in order to allow these cells that have been modified to engraft. Now, the most well-known trial is the anti-glantic globin BB111, where the hemoglobin is hemoglobin A, TA7Q, which is an anti-sickling hemoglobin that's introduced. This is 2 slides showing the age of the patients. These were patients mainly above 12 years of age and less than 50, with various phenotypes of severe disease. And the outcomes that were looked at were for 30% of this hemoglobin to be expressed, for patients to be unsupported by transfusion, and complete resolutions of vaso-occlusive crisis. This is again showing the characteristics of the patients, and there were several groups of patients treated on the study. I'm focusing here on what was published by Dr. Cantor in the New England, and this is the group C patients, where they're using mobilized peripheral stem cells, and you can see here that there were significant vector copy numbers in the cells, that the hemoglobin T87Q was significantly expressed, that the median hemoglobin level was high, and that this hemoglobin consisted of about 40 to 50% hemoglobin Ta7Q, and that these cells were really persisting there for a long period of time. Now, what happened clinically, again, decrease in markers of hemolysis like lactate dehydrogenase, like reticulocytes, like bilirubin levels. Okay, also when we look at the acute vaso-occlusive events before, if you look at severe and total number of events, there were these many, and each one is a patient, and the red dots is a severe vaso-occlusive event before treatment with the lentiglobin infusion, and none for the duration of follow-up after infusion of the lentiglobin gene. For all events, you can see them here pointed out in red and blue, the severe and the non-severe, in the 24 months before infusion, and you can see very few non-severe events after the infusion of the lentiglobin gene factor. Now, there have been other trials, and this is one that was presented recently at ASH, where they are looking to study a modified gamma globin gene expression in red cells. This is a different trial, and this is not the 872. They added a modified gamma globin gene, and you can see that in the first 3 patients that they had significant expression of this modified gamma globin gene, and hopefully this will also offer another opinion. Now, another type of gene therapy is gene editing, and here, as I mentioned, this is we edit the gene that's in the stem cells, and can be done by disrupting or correcting faulty elements within the genes, and this has been used mainly to reactivate innate fetal hemoglobin. And there are several studies ongoing. The one that has accrued most patients is the study from Vertex, where the subjects with severe sickle cell disease were with CRISPR-Cas9 technology. The BCL11A is disrupted, and the endpoints are patients with sustained high levels of fetal hemoglobin, more than 20%, and decreased VOC, increased hemoglobin, and decreased markers of hemolysis. This is a brief diagram from the New England Journal paper that showed this, showing how the BCL11A is inactivated by the Cas9, and this is showing the percentage expression of fetal hemoglobin in these patients. There were the first 3 patients were reported. These are their characteristics. They all engrafted promptly. Again, I have to say, for all these gene therapy trials, it's almost like an autologous transplant. They receive busulfan and then they treated stem cells. But you can see here that the proportion of fetal hemoglobin in these patients was significantly high, 51 to 48%, 43%, and these patients have experienced significant clinical benefit. But this study is not as advanced, and we're going to have to wait and see. Another mechanism looking at gene silencing is to switch off the BCL11 with a different mechanism. This has been done by the group in Boston. Rather than using CRISPR-Cas9, they use a lentiviral vector, and they lead to post-transcriptional genetic silencing of the BCL11A. Again, they have reported on 6 patients where there was significant increase in fetal hemoglobin production and significant clinical benefit. Now, with this, I will come to the end of my talk, and with the motto of our sickle cell patient organization here in Lebanon, I am sickle cell. Thank you very much for your attention, and again, I'm really sorry I couldn't be there with all of you, my friends and colleagues.